Hi, my name is Kip Neiman. I'm going to continue on with my Fluent tutorial. And so, since the last video, I closed Fluent and I closed Workbench, and I did that thing where I take the folder and I zip it. In this case, I named it Recorded Example 2. So this is just so I have a backup point to go to. So before I move on with more information about how to do this, the next part is to actually write the UDF. So I want to talk, before looking at UDFs, I want to talk about the ANSYS Fluent manual. Specifically, you want the Fluent customization manual. This is a manual that contains all the information on UDFs, such as syntax and how they work, examples, etc. You can go to this link here, and what you can do is actually download the entire manual as a PDF, which I think is more convenient than looking at it on their website. As what you can do in the UDF is you can hit Control F and basically search for a term you want to know more about, and it'll come up with all instances of that term. So that's really useful if you have questions about something that I'm talking about here. So next I want to talk about some common terms in UDFs and in Fluent and in coding in general. Basically, you have a mesh that represents your geometry. It basically divides it up into a bunch of little cubes. There are different names for the different parts of this geometry, basically nodes, edges, faces, and cells. Nodes represent points, such as in the corner of these little squares, and this top figure is for a 2D simulation, two-dimensional simulation. The bottom is for a three-dimensional. In a three-dimensional simulation, there's nodes at all the corners. Again, these are individual points. Edges are basically lines that connect the points only in a 3D geometry. There are no edges in the 2D geometry. And that's because the lines that connect the point to 2D geometry are called faces. So that's what's shown here. In a 3D geometry, the faces are actually two-dimensional, and they represent like the surface of one of the cells. And finally, cells are basically the control volume in which a domain is divided into. So in 2 dimensions, cells are squares, and in 3 dimension, they're cubes. Another concept talked a lot about in the manual I mentioned, the Fluent customization manual, is the concept of a thread. A thread is basically a grouping of either nodes, edges, faces, or cells. So for example, you could have a node thread, which is a grouping of nodes, or a face thread, which is a grouping of faces, etc. And you can kind of think of threads to be the same as what's called zones in Fluent. And so if you look in the Fluent simulation, if you look under either cell zone conditions or boundary conditions, you'll see these little ID numbers. So ID equals 2, ID equals 5, ID equals 1. You can kind of think of these as basically different threads, but they're called nodes. And they are called zones in Fluent, but they're called threads in this manual. And so one thing that's common in a lot of UDFs that you write is that the Fluent manual will tell you basically to define pointer variables. And I'll talk about more about this later, but basically a pointer is a general coding term. It basically references a location in computer memory. So basically it's a variable that represents where your information is being stored on the computer. Looking back at the geometry, something called a domain is basically a grouping of threads. So it could be node, face, and or cell threads grouped together. That's called a domain. And one concept you'll see a lot in the Fluent customization manual is a concept called an index. And I'm not entirely sure what this means. I believe it's something that's a variable that's being indexed through in some sort of loop. But I'm not going to say more than that because I'm not entirely sure if there's any generality to that. And so next I want to talk about how do you create a UDF. So really, let me delete this. Really the easiest way I think is to open Notepad. So if I go Notepad, and then you can type some of your code in or whatever you want to type in here, but what's important is how you save it. So if you go File, Save As, I'm in my folder, and so instead of saving it as a .txt file, we can save it as a .c file. Is that right? .c? Yeah, because it's C programming language. So save as, if I change this from text document to all files and then type something like my UDF name .c and hit save, then I can close this text, close the notepad, and then now I have a C file representing my UDF name. And so what I recommend is one nice program to use when you want to look at these UDFs is actually called Notepad++. So you can use Notepad++ after you've downloaded it by right-clicking on the file and go to Edit with Notepad++. And so I'm going to delete this because I already have my UDF written, and I call this wall profile. So I will edit with Notepad++. What's nice about Notepad++ is that it shows these sort of different colors representing different things, which is a little convenient. And so I want to go through and explain what the different parts of this code are.